Hey, geometry students. Today we're going to be looking at three-dimensional figures. Today's objective is to identify the types of three-dimensional figures. So we're going to jump right into it. Today we're going to identify them. Tomorrow we're going to do surface area and volume of the three-dimensional figures. But for today we're just worried about identifying them. So identify three-dimensional figures. A solid with all flat surfaces that enclose a single region of space is called a polyhedron. So a polyhedron. Each flat surface or face, so another word for the flat surface is a face, is a polygon. The line segments where the faces intersect are called edges. And the point where three or more edges intersect is called a vertex. Below are examples and definitions of polyhedron and other types of solids. So I want to point out this figure real quick. So the face would be all of these shapes. That's a face, and so forth. The vertex would be here because you would have one intersection, two intersection, three intersections. So three or more intersections, it would be a vertex. So this would be a vertex also. You have one, two, three. So each one of these edges, not edges, but the points, they make V's. Those are vertices. The edge, however, is just the lines. It's the lines where they intersect. So those are all edges. All right. So a polyhedron polyhedrons, we can either have a prism or we can have a pyramid. All right. A prism is a polyhedron with two parallel congruent faces. That means the two bases are the same. So if you look at this top base, it is a pentagon. 1, 2, 3, 4, 5. And the bottom base is also a pentagon. 1, 2, 3, 4, 5. And they're both the same. And they're connected by parallelogram faces. So the faces that are connecting them is 1, 2, this one back here, which would be 3, 4, and so on. All right, so the bases are the same. Well, now a pyramid is a polyhedron that has a polygonal base. So the base is some sort of polygon. In this case, it's a rectangular base or a square base. And three or more triangular faces. So they come to a point. A pyramid will come to a point, and all these faces are triangles. As you can see. So they're triangular. So those are polyhedrons. Those are two types of polyhedrons that you're going to have to understand. So there are things that are not polyhedrons. The things that are not polyhedrons, the best way to know this is circles. They have circles. One of their shapes is a circle. So a cylinder is a solid with a congruent parallel circular basis. So the top base and the bottom base are both congruent circles. So that is a cylinder. A cone is like a pyramid, but it comes out of one base is a circle. And a sphere is a ball. It's a set of points in space that are the same distance from a given point. A sphere has no faces, edges, or vertices. If you notice that the cone has a single vertex and whatnot. So here's a list of other ones that you would do well to draw these out on your own on a separate sheet of paper. You would do well to memorize these. Look at these. So this is a triangular prism. If you notice, it's a three-sided shape, but there's no point. It's a prism. A rectangular prism There we go. It's the rectangular polyhedron, but it's rectangular pentagonal prism, triangular pyramid. So those were prisms. Now we're looking at pyramids. If you notice, the prisms, they all have congruent bases, but the pyramids, they come to a point. That's our vertex right there. That's our main vertex right there. That's our main vertex up at the top. Up at the top. So if you're noticing, those are pyramids. So we're going to go ahead and do an example together and determine whether each solid is a polyhedron. Then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. So this first one, the solid is formed by polygonal faces, right? So it is a polyhedron. So it is polyhedron. So that one is a polyhedron. We're going to name the bases. The bases are going to be this bottom one. It's a rectangle. So we would say rectangle, and we don't have to write it out. We could just draw it. Rectangle, MNOP. And that's just the bottom base. Now the top base is RSTQ. So RSTQ. Next thing we're going to do is name the faces. The faces are these parts here. So let me do that in a different color. We'll go black. These parts here are the faces all the way around. So there are how many faces? And the bases also count as a face as well. So there's 6 faces. So faces, we have rectangle RQPM. We have rectangle RSN, RS, RSNM, this back face, RSNM, that's the back face. And then we have STON, STON. STON. And then we have TOPQ. TOPQ right here. TOPQ. And then we have our 2 bases. They're also considered faces, so we'll put them in there as well. So MNOP, and we have RSTQ. So that's our bases, our faces. Next, we're going to do our edges. Edges. We'll do edges in red. Our edges. Now, our edges, remember, they are lines. So RN, and there's going to be a lot of these. So RN, we have RS, RS, we have ST, ST. I'm just doing the top for now. TQ, TQ. Then we'll do our going downs here. So we have RM. We have SN. We have TO. We have QP. And then we'll do these ones. MP. we have PO, we have ON, and we have NM. NM. And then the last thing we're going to do is our vertices. Our vertices. Our vertices are just going to be all the points. So M, N, O, P, Q, R, S, T. That's it. M, N, O, P, Q, R, S, T. And remember, we don't have to worry about putting any lines or anything because they're just points. So we put commas in between them. But that is A. It is a polyhedron. Now, notice that this next one, it's curved. Because it's curved, it's not a polyhedron. So not a polyhedron. So it's not a polyhedron. It's actually a cylinder. So it's a cylinder. And since it's not a polyhedron, we don't have the bases, we don't have the faces, the edges, and vertices. We're not worried about that. This next one, you'll notice it's a pyramid. And we know that pyramids are. So yes, polyhedron. And we're going to go through, we're going to name our bases. In this case, there's only one base, and it's triangle ABC. So triangle ABC is our base. And then we're going to name our faces. So our faces, well, that triangle ABC, that counts as a face, so we're going to have triangle ABC again. But then we're going to have ADC, this triangle, ADC. So triangle ADC. And then so that was ADC. And then we're going to do CDB or BDC or BCD. Either, as long as those three are together, it's fine. So triangle CBD. We'll go CBD, that's fine. And then the last one, we have the back side, BAD, bad. Triangle BAD. And that's our faces. Next thing we're going to do is our edges. And remember, our edges are lines. So we have AD. We have DC. That's a D. We have DB. So those are the ones with D, right? AD, CD, BC. So D's done. Now we have BC. And one way you can do this, we already finished everything with D, so now we're going to work with what we have with B. So we have BC, we have BA, and if you notice, we have BD, but we already did BD. So now that means we're done with B. So now we're going to go with C. We have CD, we already have CD. We have CB, we already have CB. So then we're just left with CA. So that's done. And then, so we have A. So we have AB. We already have AB. We have AD. We already have AD. And we already have AC. So those are our edges. And then lastly, we're going to say, what are our vertices? So we have our main vertex is D. That's our big point. But if you notice, A has 1, 2, 3. So A is a vertex. C has 1 line, 2 lines, 3 lines. So C is a vertex. And B also has 1, 2, 3. So B. And so that's it. you have labeled them polyhedron or not polyhedron, and you've labeled the sides. We're going to look at this real quick. This is the last thing we're going to look at. A polyhedron is a regular polyhedron if all of its faces are regular, congruent polygons, and all of the edges are congruent. That means everything has to be congruent. So, you'll notice that this has 3 triangles that are all the congruent. And then the base is a triangle that's all congruent. So that's a tetrahedron. They're all congruent. A hexadron or a cube, we like to call these cubes, they all have the same square faces. They're all congruent. They're all the same. So if you notice that, there's 6 of them, and they're all equal. An octahedron, you're going to have 8 equilateral triangles. That's a lot, but that's an octahedron. Dodecahedron is 12 regular pentagonal faces, so there's 12 pentagonal faces on all of these. And then you have icosahedron, and that's 20 equilateral triangular faces. So there's 20 equilateral triangles. Just cool to know, but nothing too crazy. So that's it for today's lesson. Tomorrow we're going to do surface area and volume. Thanks, guys.